The first meta-analysis that I did used the standard raw data. So if I go to Analyze Meta-Analysis, Continuous Outcomes, Raw Data, and by raw data I mean the unstandardized mean differences. So not just raw data, but the specific mean differences. What I could have used instead is an actual effect measure, something like Cohen's d. What I'm interested to find out is, does this make a significant difference to the output of the analysis? Now, it's not going to make any difference, or it shouldn't make any difference to the funnel plot, but it might make a difference to the forest plot. Because everything is point and click and easy to do in SPSS, I will just change that and press OK and see what happens. Here, following directly on from the first analysis, is the new analysis. So if I look at it, does it look the same or does it look different? Now, the first thing is, it's going to have changed its units because of the way Cohen's d's worked out. Now, Cohen's d, depending on the magnitude of the d, depends on how powerful that effect size is. So this has given a Cohen's d effect size of 0.31. Now, if I look at Cohen's d and the size of effect size, effect size ranges. So the suggestion was small is 0.2, medium is 0.5. This suggests an effect between, well, closer to small, but between small and medium. The funnel plot looks identical, which is what it should do. What are the other differences in the forest plot? So if we're looking at the weights, they're all roughly about the same, roughly about 9, with Ito being down-weighted, Ito and Sahin being down-weighted. Ito and Sahin are down-weighted in the first one. The weights are slightly different, 10.18 compared to 9.88. It makes a small difference to the homogeneity. So the Q is slightly smaller. And the I squared is exactly the same. So apart from changing the numbers, almost everything looks about the same. The reason why it's interesting is the Cohen's d effect size is an unbiased view of effect size. So they're small, medium, large in terms of effect size. It doesn't matter what your units are. It doesn't matter how you've measured the scale. Now, when we had the original set of slides that I did about the VAS score and how you judge whether it's a clinically significant difference, they were saying a clinically significant difference is 1.2 units. The difference that we got is 0.6, which is half what they would say is a clinical difference. But when looking at it from the Cohen's perspective, which is an absolute measure, this is suggesting there is a small to medium effect, closer to small rather than medium. So this gives a better perspective about whether we think that effect that you found from the study is believable or not.